Welcome to class, everyone. Today we'll be talking about quantities. In physics, the basic quantities are the fundamental quantities, derived and supplementary quantities. Now we are going to be starting with what a quantity is. A quantity in physics refers to any property of a substance or matter that can be measured or calculated. Example includes time, length, mass, volume, force, area, etc. Looking at the basic example we have here, what is the length of the line AB? For us to know the length of a line AB, we have to use an instrument, which is our ruler, or we call it rule. So you use it in terms of centimeter. We've got 14 centimeter. We've got an approximate of 14 centimeter. If we measure it in terms of inch, we are going to get 5.5 inches. Now, while representing quantities with this, note that the 14 here is the magnitude and the centimeter is the unit. 5.5 also represents the magnitude, while inches represents the unit. Quantities can either be fundamental, derived, or supplementary. Fundamental quantity. Fundamental quantities are independent of other quantities and can be measured directly. Examples include mass, whose unit is in kilogram, length, whose unit is in meter, time, whose unit is in seconds, luminous intensity, whose unit is in candela, amount of substance, whose unit is in mole, current, whose unit is in amperes. A typical example of direct measuring instrument includes your beam balance used for measuring mass. It stems from your simple beam balance to your chemical beam balance to your spring balance. Time used to be measured in the olden days with a sun clock. Now, the evolution of the measurement of time stems from the sun clock to the stopwatch. Now, we also have what we call the wall clock. Length can be measured depending on the length of what you are measuring. We can use a tape rule, a steel rule, or a measuring tape. When we talk of luminous intensity, it can also be measured directly using the luminous intensity meter, or what we call a lux meter. Now let's talk about derived quantities. These are quantities obtained from the combination of two or more fundamental, derived, or even both the derived and fundamental quantities. Examples include volume. Volume is the length multiplied by the breadth and height of a substance. Hence, the unit of volume is in meter cube because length, breadth, height are all measured in meters. Density is the mass per unit volume. Hence, the unit is in kilogram per meter cube. Pressure is the force per unit area of a substance. Hence, the unit is in Newton per meter square because the unit of area is meter square. Force is the product of mass and acceleration. Hence, the unit is in Newton. Surface tension is the force per unit length acting perpendicularly on the surface of a liquid, causing it to act like an elastic skin. Hence, the unit is in Newton per meter. Moment is the product of force and perpendicular distance. Hence, the unit is in Newton meter. Impulse is the product of force and time. Hence, the unit is in Newton seconds. So you can see why all these are considered as derived quantities. Their units are also derived units because it requires the combination of two fundamental quantities or two derived quantities, or even the combination of a fundamental and a derived quantity. It is paramount to know that some derived quantities can also be measured directly, like your volume. It can be measured, especially the volume of a liquid. It can be measured using a beaker, conical flask, measuring cylinder, and the rest. Your force in terms of weight can be measured using a spring balance directly as well. So let's talk about supplementary quantities. These are dimensionless quantities. Examples include plane angle, whose unit is in radian, and also solid angle, whose unit is in star radian. Next, we are going to start solving past questions on fundamental, derived, and supplementary quantities. Looking at this jam past question, we have a dilemma in our hands. The question goes as thus: which of the units of the following physical quantities are derived? I, area; II, thrust; III, pressure; IV, mass. Let's pick it apart one after the other before we come to conclusion on which answer is actually the correct one. Area is gotten by multiplying length and breadth. Thrust is a form of force, which is the mass times acceleration for a body moving upwards. Pressure is the force per unit area, so it requires the combination of force and area. Mass is the quantity of matter present in the body, and it is a fundamental quantity. Hence, B is the correct answer. The next question is a jam question which states which of these is a derived unit. Kilogram is the unit of mass. Mass is a fundamental quantity. Hence, kilogram is a fundamental unit. Meter is the unit of length. Meter is a fundamental unit. Newton is the unit of force. Force is a derived quantity. Hence, Newton is a derived unit, making C the correct option. And without abandoning D, D is second. Second is the unit of time. Time is a fundamental quantity. Hence, second is a fundamental unit.